dive. We're going to be exploring some pretty interesting sources. We've got excerpts from articles on archaeometric dating. We've got information about the geological formations of the Grand Canyon. We'll also be looking at biblical chronology. And we even have some scientific papers that were presented at the International Conference on Creationism.
It's an eclectic mix, wouldn't you say?
Yeah.
It's going to be pretty interesting to see how these sources connect and maybe even clash a little bit.
Okay. So basically, we're going on this journey through time and evidence, exploring how different fields interpret, well, everything from ancient civilizations to the Grand Canyon to even the very origins of humanity.
And as you might imagine, those different perspectives don't always agree.
That's what makes it so interesting, right? We'll be looking at the traditional scientific interpretations and then some alternative perspectives as well.
Exactly. We'll be exploring the traditional interpretations of geological formations, but we'll also be diving into some alternative views, like those based on a literal interpretation of the Genesis flood.
Right. And that actually brings us to our first topic. This one really grabbed my attention right away. It's all about the magnetic field of the past.
Ah, yes. You know, researchers have been studying these inscribed bricks from ancient Mesopotamia. This helps to, corroborate biblical history. And they found something pretty remarkable. It turns out the Earth's magnetic field, well, it wasn't always as we know it today. It was actually, get this, more than twice as intense in the past.
Wait a minute. So I always thought the Earth's magnetic field was like this constant, steady force. Are you saying it's actually changed over time?
Yeah, it has. It's changed a lot, actually. And what's even more interesting is that it was changing rapidly during the time of the biblical kingdoms of Israel and Judah.
So what does this mean for the age of the Earth? I mean, does this support a younger Earth, as described in the Bible, or does it kind of line up with that conventional view of billions of years?
That's a tough one. You know, that's a question that sparks a lot of debate. And frankly, to really get a clear picture, we need to look at the evidence from different angles. But this finding, it definitely challenges that standard geological timescale, the one that assumes these really slow processes over millions of years.
Okay, so it's not a simple answer, but it's definitely something to think about.
Absolutely. It really highlights how seemingly unrelated fields, like archaeology and geophysics, can come together and kind of force us to rethink our understanding of the past.
All right, well, let's move on to the next source. This one takes us to the Grand Canyon. Specifically, it focuses on a formation called the Tapeats Sandstone.
Ah, yes, the Tapeats Sandstone. It's like a giant history book written in stone. It gives us all these clues about ancient environments and the powerful forces that shape the planet.
Right. Our source describes it as a thick layer, sometimes over 100 meters thick, and it's made up mostly of quartz, K-feldspar, and muscovite.
It's a really fascinating formation.
Yeah, it is. What I found really interesting was this description of pancake layering. Apparently, it indicates ancient water flow patterns. What exactly does that mean?
These pancake layers, which are more formally called amalgamated channels, they were formed by these powerful storm-like surges of water.
Okay, so huge amounts of water moving really quickly.
Exactly. Imagine these massive surges shaping the landscape. You've got water flowing sometimes north, sometimes southwest.
Yeah.
And all this while, there's this massive northwest-southeast ridge being buried by sediment.
Wow. I mean, that paints quite a picture. But there's a puzzle here, right? The Tapeats Sandstone, it sits on top of something called the Great Unconformity, and that's described as this massive erosion surface. What's the significance of this Great Unconformity?
Yeah, so the Great Unconformity is a big point of disagreement between conventional geology and flood geology. See, conventional geologists, they see it as evidence of vast stretches of time, maybe representing millions of years of erosion. But flood geologists, they've got a different explanation. They think it formed rapidly. Catastrophic erosion during the early stages of the Genesis flood.
So two very different interpretations of the same thing.
Exactly. And each one has huge implications for how we understand the age of the Grand Canyon and the processes involved in its formation, of course.
What else does this source tell us about the Grand Canyon?
It also mentions something called the Matkatamiba Fold.
Matkatamiba Fold.
Yeah, it's another really fascinating feature. And, this fold has sparked debate, too, whether its formation involved millions of years of slow deformation or maybe rapid soft sediment deformation.
So again, we had these two different interpretations.
You got it. And that rapid deformation could have happened during a catastrophic event like, the flood.
So every layer of the Grand Canyon seems to hold another mystery.
It really does.
All right, let's shift gears a bit. Let's go from rocks to biblical texts. What about biblical chronology?
Ugh.
Ah, yes, biblical chronology. Well, it presents us with some interesting challenges, particularly the genealogies in Genesis 5 and 11. It turns out there are different interpretations of those texts,
Okay.
and those discrepancies can really affect our understanding of early human history.
Can you clarify what you mean by discrepancies for someone who's maybe not familiar with biblical chronology?
Sure. One source highlights these conflicting chronologies you find in the Masoretic text, which is, the Hebrew text for most English translations of the Old Testament.
Mm-hmm.
Then there's the Septuagint,
Oh, yeah. The Greek translation.
right, the ancient Greek translation of the Hebrew Bible. And then you have the writings of Josephus, the first century Jewish historian.
Right.
These different chronologies can actually shift our understanding of early human history by hundreds, even thousands of years.
Thousands of years. Wow, that's a huge difference. I mean, those different chronologies could potentially change our entire understanding of the timeline of early human history. Absolutely. The source presents a really compelling case for the Septuagint containing the original Genesis chronology.
Okay, so how does that compare to the Masoretic text?
Well, the Septuagint has those longer lifespans for the patriarchs. And this argument draws on comparisons with, the Samaritan Pentateuch, Josephus, the Book of Jubilees, even other ancient sources.
And if that Septuagint chronology is right, how would that change your understanding of, the biblical timeline?
Well, for one, it would push back the dates of key events like the flood and the Tower of Babel. It could potentially align them more closely with certain archaeological findings.
So it's not just an abstract theological debate, it has real-world implications.
Exactly. But it's important to remember that this is an ongoing debate among scholars with strong arguments on both sides.
Right, of course. We're simply presenting the information as it's found in the source material. Now, I'm curious about this source on the Ipura papyrus. It sounds like it might connect to the biblical Exodus in some surprising ways.
Yeah, so the Ipura papyrus describes this period of chaos and upheaval in ancient Egypt. And some scholars believe it actually contains these striking parallels to the biblical account of the Exodus.
Really? What kind of parallels are we talking about? What exactly does the papyrus say?
Well, it describes some pretty dramatic events: the river turning to blood, widespread famine, social unrest, death on a massive scale.
Those are some pretty heavy themes. And all of those calamities, they're also described in the Exodus narrative.
Yes, they are.
So are these parallels enough to link the Ipura papyrus definitively to the Exodus?
It's tricky. There's a lot of debate about the dating of the papyrus and whether it truly relates to the Exodus. Some scholars think the events described in the papyrus belong to a different period in Egyptian history.
So it's still up for debate. But it's fascinating to think that this ancient Egyptian text could corroborate, a key event in biblical history.
It really is. It shows how these ancient sources can sometimes shed light on each other in unexpected ways.
Now, let's move on to a topic that seemed at first a bit out of place to me, the coal gap.
Ah, the coal gap. It refers to this curious absence of coal seams in early Triassic strata. It's a specific period in geological history.
Okay.
And this gap is particularly interesting because it follows the formation of those massive Permian coal fields found in places like Australia, India, Southern Africa, all over the world, really.
So we have these huge coal deposits from the Permian period, then a gap in the early Triassic,
Yeah.
and then coal formations reappear later on.
Right.
So what could explain this gap?
Well, conventional geologists, they link those Permian coal fields to the late Paleozoic Ice Age.
The Ice Age. Right?
Yeah, and they explain their formation over really, really long periods,
No.
millions of years.
Right. But our source seems to suggest that a catastrophic model might actually be a better fit.
Yes, exactly.
What would that model look like? How could that explain these coal deposits?
Well, imagine a scenario with really rapid processes, like those associated with the Genesis flood. Massive amounts of vegetation are suddenly uprooted. They get transported by floodwaters. And then they're rapidly buried under sediment.
Okay, so we're talking about a sudden, dramatic event, not a slow, gradual process.
Exactly. And that heat and pressure from that burial, that could rapidly transform all that vegetation into coal.
So the coal gap, like a lot of these other topics, presents an opportunity to look at things differently, to consider interpretations that might challenge the conventional timeline.
Right. It's about being open to different possibilities and how they might change our understanding of the geological record.
I'm ready for something a little less, rocky. Let's delve into this source on symbiotic relationships. It sounds fascinating.
Symbiotic relationships are amazing, aren't they? They really show how interconnected life on Earth is. This source goes beyond those traditional evolutionary models and introduces this concept called guided interface design.
Okay, break that down for me. What's guided interface design in the context of symbiosis?
Think of it like this. When two organisms, engage in a symbiotic relationship, whether it's mutualistic, commensal, or even parasitic, they need to communicate and exchange products or services.
Right, they need to interact in some way.
Right. And that interface, that's where that interaction happens. That's where things get really interesting.
So there's an actual mechanism between these organisms.
Yes. And this communication system involves these complex protocols. There are authentication mechanisms. You even have common media, just like in computer science.
Wow.
The source highlights how the intricacies of these interfaces, the complexity of this communication might actually point toward intelligent design, not just random evolutionary processes.
That's a really intriguing idea when you
Right.
think about those nitrogen-fixing bacteria in plants or those complex mechanisms that parasites use. It does make you wonder.
Exactly. It's not just random chance. There's a level of design there.
Can you give me an example of what you mean by guided interface design?
Sure. Let's take mycorrhizal fungi in plants. The fungi, they extend their hyphae into the soil. That increases the surface area for nutrient absorption. And then they transport those nutrients, things like phosphorus and nitrogen, to the plant roots.
Okay, so the fungi are helping the plants.
Exactly. And in return, the plant gives the fungi sugars from photosynthesis.
So it's a mutually beneficial relationship.
Yes. But this exchange, it requires a complex communication system. You have signaling molecules, receptors that allow the two organisms to recognize and interact with each other. It's not simple at all.
It's amazing how much is going on at that microscopic level.
It really is.
Okay. It seems like we've gone from magnetic fields to rock formations, biblical texts, and now symbiotic relationships. What's next on our journey?
Next up, we're going to talk about radio halos.
Radio halos. Okay.
Yeah, they're basically microscopic scars left behind by radioactive decay.
How does that even work?
Well, they're formed by these alpha particles. These particles are emitted from uranium decay within tiny zircon crystals, so they offer physical evidence of these radioactive processes in the rocks.
Okay. So how do these radio halos relate to the whole age of the Earth debate?
That's where things get really interesting. Radio halos, they're supposed to be annealed or erased at temperatures above 150 degrees Celsius.
Okay.
But scientists have found them in Precambrian rocks, and those rocks, they're conventionally thought to be billions of years old, and they should have experienced temperatures way higher than that threshold.
So how could they have survived?
It's a paradox, isn't it? And one explanation is that there might have been these periods of accelerated nuclear decay.
Accelerated nuclear decay.
Especially during a catastrophic event like, the Genesis flood.
So potentially faster decay rates. And that could explain why these radio halos are still around in rocks that are supposedly billions of years old.
That's the idea.
Okay, so this is another example of how the evidence might be interpreted in different ways.
Absolutely. It's a concept that's difficult for mainstream science to accept, but it does offer a potential solution to this puzzle.
Right. And for our last stop on this part of the deep dive, let's turn to the human brain.
The brain. The most complex organ in the human body.
It's incredible, isn't it?
It really is. And this source we're looking at presents a very interesting idea. It suggests that the exceptional capabilities of the human brain, those that far exceed any other animal, could reflect the imago Dei.
The imago Dei.
Yeah.
You're saying the image of God.
Yes. The source explores the architecture of neurons and neural networks, even drawing parallels to the full compute stack model they use in computer science.
Okay, tell me more about this model and how it connects to the brain.
So the full compute stack model describes the different layers of a computing system. You have the hardware at the bottom, the software applications at the top. Each layer builds on the one below it. And that creates this complex, integrated system that can do all sorts of things.
Right, I get that.
And the source suggests that the human brain, with its network of neurons and synapses and pathways, it might be viewed as a full compute stack, too. But here's the thing. To really capture all that the human brain can do, we might need to add an extra layer to the model.
An extra layer.
Yes. And this extra layer hints at abilities that go beyond just the material processes.
So we're talking about something beyond the physical structure of the brain, something more.
Exactly. It suggests a dimension of human consciousness that might not be fully explained by the physical brain alone.
So maybe a spiritual dimension to human consciousness.
That's one way to interpret it, and it raises some really big questions about the nature of consciousness, the soul, what it means to be made in the image of God. It's all connected.
Wow, this deep dive is really making me think in new ways.
Ugh.
We've gone from the depths of the Grand Canyon to the mysteries of the human brain. It's amazing how these different topics start to connect when you look at them from this perspective.
I agree. And in the next part of our deep dive, we're going to explore those connections even further. We'll delve into those potential conflicts, but also convergences between scientific evidence and biblical interpretations. It's going to be fascinating.
Welcome back to the deep dive. Last time, we were talking about how Earth's magnetic field was much stronger in the past. I mean, that really got me thinking.
Yeah, it's a finding that definitely makes you question that traditional view of Earth's history, that idea that everything unfolded over these vast stretches of time.
Right. Because according to conventional geology, the Earth's magnetic field is supposed to be generated by the movement of molten iron in the Earth's core,
Yeah.
right? And that's driven by these slow, gradual processes over millions of years.
Exactly. But if the magnetic field was changing so rapidly, like that research on those Mesopotamian bricks suggests, wouldn't that mean something more dramatic had to be happening, something faster?
Yeah, it seems like it. So
Yeah.
what could explain that?
Well, some researchers believe that these rapid and really significant changes in the magnetic field are better explained by a catastrophic model. This model might involve large-scale shifts in the Earth's core, maybe during some kind of global event.
Like the flood.
Exactly, the flood.
So essentially, we're looking at two totally different explanations for the same thing. Slow, gradual processes versus rapid, catastrophic events. And those two explanations, I mean, they have implications not just for how we understand the Earth's magnetic field, but for how we interpret the whole geological record, don't they?
Absolutely. It really underscores how important it is to look at things from different angles, to
Yeah.
consider different perspectives and how they might shape our understanding of the past.
Speaking of different perspectives, let's get back to the Grand Canyon for a minute. Those layers of tapete sandstone, we were talking about those pancake layers or amalgamated channels that were formed by ancient water flows. But what about the composition of the sandstone itself? I mean, what can that tell us about how it formed?
Good point. The source mentioned that the Tapete sandstone is made up mostly of quartz, K-feldspar, and muscovite.
Right. But what's so special about those minerals?
Well, the interesting thing is, those minerals are very similar to the minerals found in the underlying basement rocks. So it suggests that the sediment that makes up the Tapete sandstone actually came from those older rocks. It was eroded from them.
So instead of the sand being transported over long distances, it was already there.
Exactly. It was locally derived.
What does that tell us about how the tapete sandstone formed?
Well, the source points out that the composition of the sandstone, along with things like those mica schist and siltstone fragments they found, suggests that the sediment wasn't transported very far, and it probably happened really quickly.
So again, it's more consistent with a sudden, powerful event rather than slow and gradual erosion over millions of years, right?
Right. And that lines up with the flood geology model. People who support that model propose that the Tapete's sandstone, and maybe even a lot of the Grand Canyon's layers, were formed during that global flood event described in the Bible.
Now, I remember we briefly mentioned something about detrital zircon U-peep ages from the Tapete's sandstone.
Yeah.
Can you refresh my memory on what those are and why they matter in all of this?
Sure. So UP beating, it's a method that scientists use to try to figure out the age of rocks. It's based on the radioactive decay of uranium. It's actually one of the main tools that conventional geologists use to construct that geological timescale we've been talking about.
Right.
But the zircon ages they got from the Tapete's sandstone, they've caused a bit of a stir
How so?
because a lot of them are much younger than the conventionally accepted age for the sandstone.
So if these zircon ages are accurate, then the Tapete sandstone is actually younger than we thought.
That's what it seems to indicate.
And what does that mean for the bigger picture?
Well, for one thing, it raises questions about how reliable the UPB dating method really is, at least when it comes to these particular rocks. The source points out a bunch of potential problems with the method, things like lead mobility, the way uranium and lead can be separated, even those assumptions about constant decay rates that are kind of the foundation of the whole method.
Okay, so if there are problems with the UPB dating method, then does that mean we might need to reassess the whole timeline for the Grand Canyon?
Some researchers think so. They say the evidence, including those zircon ages, suggests that the Tape sandstone is actually much younger, and maybe even the whole Grand Canyon is younger.
And of course, that would fit better with the biblical timescale.
Exactly.
Let's switch gears again, back to biblical chronology. We were talking about those different interpretations of the Genesis genealogies. You mentioned that these discrepancies, the differences in how people interpret those genealogies, they could shift our understanding of early human history by thousands of years.
Mm.
Can you give us some concrete examples of what you mean?
Sure. Let's take the date of the flood, for example. The Masoretic text, it puts the flood around 2348 BC. That's the date most people are familiar with. But the Septuagint, remember that Greek translation of the Old Testament, it gives us a different date, around 3048 BC.
That's a difference of 700 years?
It is. And that difference, if the Septuagint is right, it means the flood would have happened before the rise of a lot of those major Mesopotamian civilizations.
Wow, that's huge. I mean, it would totally change how we understand the development of those civilizations
Yeah.
and their relationship to the biblical narrative.
Exactly. It would challenge a lot of conventional interpretations of ancient history.
And what about Josephus? You mentioned him earlier. How does his chronology compare to the Masoretic text and the Septuagint?
Josephus, his timeline generally lines up better with the Septuagint. He even refers to those longer lifespans of the patriarchs, the ones that are in the Septuagint. So that adds more weight to the idea that maybe the Septuagint is closer to the original.
So we have multiple ancient sources that seem to support a longer chronology for early human history.
Right. It's something to think about.
Now back to that Ipuwer papyrus and the Exodus.
La.
What are some specific details from the papyrus that actually seem to parallel the biblical plagues? Like, what are the similarities?
The parallels are pretty amazing, actually. The papyrus talks about the Nile turning to blood. That's a direct match for the first plague. It also mentions famine and social unrest, which lines up with those plagues of locusts, hail, and darkness that devastated Egypt's crops and economy, according to the Bible.
Right. Those are some pretty big similarities. What about the final plague? The death of the firstborn. Does the papyrus say anything about that?
Well, the papyrus does talk about a lot of death and suffering. It really emphasizes that. So, in a way, it echoes the devastating impact of that final plague. And while the connection to the Exodus is still something people debate, you can't just dismiss these parallels.
No, you can't. It's really intriguing to think that this ancient Egyptian text might actually provide evidence for the events described in the Bible.
It definitely makes you think.
Okay, now I want to circle back to that coal gap. I'm still curious about the formation of those massive Permian coal fields that existed before the gap. How would a catastrophic model explain those?
Remember, conventional geology says those coal fields formed from slow processes over millions of years, right?
Right. They usually link them to that late Paleozoic ice age.
Exactly. But when you look at the sheer scale of these coal fields and the fact that they're found all over the world on different continents, it suggests that something much more dramatic might have happened.
So what could possibly bury that much vegetation so quickly?
Well, a global flood, like the one described in the Bible, would be a pretty good explanation. Imagine huge amounts of vegetation ripped up and transported by floodwaters, then rapidly buried under layers and layers of sediment. The heat and pressure from that burial could quickly transform all that vegetation into coal.
It seems like a flood of that magnitude would definitely create the conditions needed to form coal deposits that massive.
Exactly. It's just a different way of looking at the evidence. And it might actually fit better when you consider the scale and distribution of those deposits.
Okay, now those symbiotic relationships, we were talking about the guided interface design model.
Yeah.
You said that model differs from the typical evolutionary explanations. Can you explain that a bit more?
Sure. So traditional evolutionary models, they usually explain things like symbiotic relationships through random mutations and natural selection.
Right.
They say that beneficial mutations just pop up randomly. And if those mutations help an organism survive and reproduce, they get passed down. And over vast periods, those tiny changes can eventually lead to these complex relationships, like we see in symbiosis.
Okay, so it's all about chance and gradual change over very long periods.
Right. But the guided interface design model, it's a bit more intentional.
What do you mean?
Well, it suggests that those communication systems, those molecular mechanisms in symbiotic relationships, they're just too intricate, too complex to have just happened randomly.
So it's not just about chance mutations.
Exactly. The model argues that the complexity we see, it points to design, to intentionality. Someone or something had to set it up that way.
What kind of evidence supports that view?
Let's look at those nitrogen-fixing bacteria again. They have this symbiotic relationship with plants, right?
Right. They live in the roots of legumes,
Yes. And they convert atmospheric nitrogen into a form that plants can actually use.
which is essential for the plants to grow.
Exactly. But that process, that back and forth between the bacteria and the plant, it involves this really complex exchange of signals. The bacteria release these signaling molecules that the plant recognizes, and that triggers a whole chain reaction that leads to the formation of those nodules where the bacteria live. And the plant, it provides the bacteria with sugars and other nutrients in return. It's this really intricate dance.
So it's more than just the bacteria randomly mutating and happening to find a home in the plant's roots.
Exactly. There's this communication, this coordination, this give and take. It suggests a level of intentionality that goes beyond random chance.
That's a really good example.
And that's really the point of the guided interface design model. It challenges us to consider another possibility, that these relationships, these intricate systems with their communication and coordination, maybe they reflect something more. Maybe there's a deeper level of design behind it all.
I'm starting to see how all these seemingly unrelated topics are actually connected in a lot of ways.
Oh.
We've gone from magnetic fields to rock formations to biblical texts to the microscopic world of symbiotic relationships.
That's how connected.
Now, what about those radio halos? We talked about how their presence in those Precambrian rocks, the ones that are supposed to be billions of years old, kind of throws a wrench in the standard geological timescale.
Mm.
How does this idea of accelerated nuclear decay solve that problem?
Remember how those radiometric dating methods, like that UP method we were talking about, they all assume that radioactive decay rates have always been the same throughout Earth's history.
Right.
And based on that assumption, they measure the ratios of parent isotopes to daughter isotopes to calculate the age of rocks.
But what if those decay rates weren't constant? What if they were faster in the past?
That's the question. Because if that's true, if those decay rates were faster in the past, then those calculated ages wouldn't be accurate.
So those Precambrian rocks, the ones with the radio halos, maybe they're not as old as we think.
That's what some researchers are saying. They suggest that if those rocks actually formed much more recently, during a period when decay rates were accelerated, that would explain why the radio halos are still there. Because if those rocks were really billions of years old, those radio halos should have been erased long ago.
And what kind of event could have triggered that kind of accelerated decay?
Well, some creation scientists think that the flood, the global flood described in the Bible, could have been a time when nuclear decay rates were much higher than they are today.
So that would have affected the formation of radio halos and the amounts of radioactive elements we see in rocks today.
Exactly. It's a controversial idea, but it could potentially solve a lot of those puzzles we see in the geological record.
Okay, so this accelerated decay, it's a challenging concept for mainstream science. But it does provide a possible explanation for those radio halo anomalies and offers a different view of the age of those really old rocks.
Right. It's about considering different interpretations of the data.
Now let's go back to that amazing human brain, the idea that our brains reflect the image of God. You mentioned that some researchers think we need to add an extra layer to those computer models of the brain to really capture what it can do. Can you explain what they're proposing?
Scientists have done amazing work, truly amazing work, in figuring out how the brain processes information. How those neural networks work that allow us to think, to learn, to create, to feel emotions.
Right. But you're saying there's more to it than that.
There are aspects of human consciousness that just don't seem to fit into a purely material explanation.
So things like self-awareness, abstract thought, moral reasoning, our spirituality.
Exactly. Those are all things that really set us apart. Even from the most intelligent animals. Think about it. Our ability to ponder the meaning of life, our desire for purpose, our spiritual experiences, those things are hard to explain if we're just physical beings.
It seems like those are qualities that go beyond the physical structure and function of the brain.
Right. And some researchers believe that those higher order capabilities actually point to a non-material aspect of human consciousness. Maybe something like a soul or spirit.
So you're saying this soul, this spirit, it interacts with the physical brain.
That's one way to think about it. And it aligns with what the Bible says about humans being created in God's image. It suggests we have this spiritual dimension that sets us apart from the rest of creation.
This deep dive is really making me think differently about our origins, about the connections between science, history, and faith.
It's a lot to take in, isn't it?
It is. What conclusions have you drawn from all this information? What are the main takeaways?
Well, it's been a pretty thought-provoking journey. And in the final part of our deep dive, we're going to try to wrap things up. We'll explore some of the broader implications of what we've discussed, what it all might mean for how we see the world and our place in it. Welcome back to our deep dive into all these fascinating topics. We've gone from the Earth's magnetic field to those mysteries of the Grand Canyon. We even talked about biblical chronologies and those complex symbiotic
And
relationships.
those tiny radio halos. And an incredible human brain, of course. It's been quite a journey.
It has a real journey through time and evidence, wouldn't you say? Exploring all these different perspectives on our origins and the forces that shape the world.
As we wrap up this deep dive, I'm wondering what you see as the main takeaways from all these sources. What are the big picture insights that really stand out to you?
Well, I think one of the most significant takeaways, at least for me, is that the conventional timeline of Earth's history, the one that assumes those millions and billions of years, it's not as solid as we're often led to believe.
Yeah, I'm starting to see that too.
The evidence we've talked about, from those rapidly changing magnetic fields to those zircon ages from the Tethys sandstone and those radio halos and those Precambrian rocks, they all point to the possibility that the Earth might be a lot younger than mainstream science thinks.
And that younger Earth model, like we've discussed, it aligns better with a biblical timescale.
It does.
And it seems like one of the big themes in this deep dive has been the importance of considering different interpretations, interpretations that might challenge those prevailing views but offer a new perspective on the data.
You're absolutely right. Take flood geology, for example. It provides a different lens through which to view the geological record, one that can potentially explain things like the rapid formation of these massive rock layers, those fossils found all over the world, those unique features of formations like the Grand Canyon.
Those are features that don't really fit with that slow, gradual process that conventional geology usually relies on.
Exactly.
So it's not about rejecting science. It's about being open to different scientific models that might explain the evidence better. And that open-mindedness, it seems like it should extend to other fields as well, like when we talked about that guided interface design model for those symbiotic relationships.
Right, because that model suggests design, purpose, intentionality.
A level of complexity that points to intelligent design.
And that concept, that idea of intelligent design, it's often met with resistance, in mainstream science. But it really resonates with the biblical perspective, the idea that the world around us reflects the work of the Creator.
And it seems like this deep dive has really highlighted how important it is to bring our understanding of science and faith together.
I completely agree. Because those sources we've looked at, they don't present science and the Bible as being in conflict. They actually provide an opportunity to see how those two perspectives can complement each other, to enrich both our scientific understanding and our faith.
So instead of seeing science and faith as these separate, incompatible things, we can see them as different ways of looking at the same reality. Each one can help us understand the other better.
That's the beauty of it. And that leads us to what I think is the most profound takeaway from all of this: the mystery of human consciousness.
Yeah.
Because all that evidence we've discussed, especially those incredible capabilities of the human brain, it really points to the idea that we are so much more than just our physical bodies.
The more we learn about the brain, the more we realize how much we don't know.
It's true.
And those higher order capabilities we talked about, self-awareness, abstract thought, morality, our spirituality, they point to something that goes beyond just the material world.
Exactly. Those capabilities, they're hard to explain from a purely materialistic viewpoint. And they suggest that there might be a non-material dimension to who we are, something like a soul or a spirit that interacts with the physical world through our brains.
Which raises some big questions that science can't really answer on its own.
Right. Questions about the nature of consciousness, what happens after we die, what it truly means to be made in God's image.
Those are questions that people have been grappling with for centuries. And the more we discover about the brain, the deeper those questions become.
That's the beauty of it all. The mystery keeps unfolding.
I have to say, this deep dive has given me a lot to think about. It sparked a real sense of wonder in me, a desire to keep digging deeper into these mysteries.
And that's what we hope for. We want to encourage you, our listeners, to keep questioning, to keep seeking, to keep exploring. The journey of understanding the world, our place in it, it's an ongoing one, full of challenges and discoveries.
Thank you for joining us on this deep dive. We hope it's inspired you to keep exploring the wonders of creation and the mysteries of our origins.